Okay, good afternoon. Next session is Greg, who's going to talk about clearer code at scale. 大規模な分かりやすいコードについて。
Hello. All right. Hello, everyone. 皆さんはじめまして。I'm going to tell you about how we've made our code clearer in some big projects. So just a little bit about me first. So as a student, college grad school, I studied math and CS theory. Before I decided I'd rather be building code than writing theorems. Most recently, I was at Dropbox for 3 years, where Dropbox has 700 engineers, and about half of them all work in the same Python code base. So that's a lot of people all like collaborating the same code, and so my focus there was to help all those engineers, both the half in the same Python code base and people in all the other code bases, write better code, higher quality software, and to move faster to all the many new products that we want to develop, and build better systems, and learn what the right products are faster by building more things. Those are both very important problems for us. And so I and a small team focused on that. And then since a few months ago, I work full-time on Zulip. So all that is background. I'll tell you just a little bit about Zulip. So it's some of you heard this this afternoon at the poster session, but it's an open source group chat tool. And there's two big things I think that we're proud of. One is on the product side, which is that it supports, I think, higher quality conversations than you can get in IRC or its clones like Slack, because of a robust threading model. And I can say a lot about that, but this talk is more on the other. The thing that's relevant for this talk is the broad open source community that we've been able to build, which I can't actually take much credit for. I just joined recently, but my collaborators have built a really impressive large community that allows many people to show up from the internet with no experience in our code base, many of them without much experience as programmers, some of them with more, and be able to make productive contributions. And for us to be able to make use of those and to incorporate those contributions without a lot of work on our part. This is something that not many open source projects do. And it's partly because it takes some work and it takes some thought and takes some skill. But I'll be telling you basically about one of the technologies that has helped make that possible that I think is quite important. And in general, one of the key legs of how that's possible is having the code be very clear. So if somebody shows up, they can understand what's going on. And also so that as we're reviewing, we can understand their change. And we can ask them to make it very clear so we can understand it. Which lowers the burden for us to review it, which I think is the biggest obstacle for many open source projects to having more contributors. That it's work for them to use it, and so they just sort of wall themselves off. So how do we make the code clear? There's many things. Some is like standard code reviewing practice that we just are disciplined about. But one is static types. And so both Zulip and Dropbox, static types, or having clear code is very important. And in Dropbox, we actually, fortunately, we had the scale as a company to invest in solving this problem. And so we have, and we're now not the only major company that has done so. So we, in fact, wanted that clear code so much. It was so important to us for these 700 engineers, the majority of them working in Python, about half of them all working the same Python code base. It was so important to us to make the code clearer that we actually built a type checker for Python. We took a research prototype that existed, one of our employees had made as a PhD student, and we built it out into a real thing you could use. And it's all open source, and you should all use it in your Python programs. And in fact, engineers at Dropbox have picked it up. It started from 0 less than 2 years ago, at the end of 2015, when the tool wasn't even something you could really use for real yet. And it's now, as of June, the last number I have, it's over 750,000 lines, which is a lot of code, is now statically typed Python code. And by the way, all of that is Python 2.7. So it's true that there is a slick syntax that you can only get in Python 3, but you totally can do it in Python 2.7. There's a comment syntax you'll see on a slide later when I demo. And it works fine. It all works just as well. This is the MyPy core team. 4 of us are working full time of it, 3 or 4 of us for a while. You might recognize 1 or 2 faces there. Yeah, and so this is, very fortunately, Dropbox saw the value of this and supported it. These people working full time to make that static types work for Python. So, I've been talking a lot about making code clear so you can understand it. So let's be concrete. So this is a little parable, a story I've lived many times. So there's some piece of code that you're trying to understand. And it's in your code base, be it small, medium, large. And great, okay, what does this line do? It calls the method validate on a thing. Okay, well, so I could go search for a method named validate in the code base. There might be a lot of those. In Dropbox's code base, there are over 100 methods with that name. And it's not because they're all the same API, some base class, different. No, they're unrelated, independent, because it's just a good word. And a good word, people are going to use a lot. And there's a lot of good words out there. So very often, there's many things that it could be when you search. So it all comes down to, okay, great, what is the thing? What type is that? Right? That tells you what code is going to run, what function you have to look up, either the doc string if you're lucky or the implementation if you're not. Either way, which one you have to look up. Great, okay, what type is thing? Well, it could come from a lot of places. Very commonly, it's a parameter to this function we're looking at, or it is an attribute of a parameter, or it comes down to what parameter is this. So we'll take that example. Great, okay, now what type is this parameter thing to big function? Well, the thing I've done many times in the past in Python codebases, Dropbox and elsewhere, is let's go search for the call sites of the function we're looking at. Right? Go grep for the name. And if we're lucky, it's the only function with this name. If we're less lucky, we have that problem too. Maybe it's named validate itself. But even if we're lucky, now great, all these call sites, it passes some argument. We have to figure out what type the argument is, which is the same problem recursively. And if we're lucky, maybe it's like a string little or something. If we're less lucky, it calls something, or it's a parameter to that function itself. And so now we have to go pursue this problem, sorry, that's the wrong way, pursue this problem recursively, grep for the call sites of the callers, and for the callers' callers, et cetera. This huge search tree. And you read through thousands of lines of code just to understand what this one line is doing. And that is the thing that I never want to do again. And I don't want my coworkers to have to do. And so that is why we built static types for Python. So this is what it looks like. Many of you have probably seen demos of what it looks like, but very briefly to be concrete. You just, if you're in Python 3, which you hopefully are by now, you just put the annotation right next to the parameter's name on the def line. And now, boom, search done at depth 0. You know what the answer is, what type it's supposed to be, and you move on with your life. And you move on to understand more deeply what the code is doing now that you have this basic fact. And just to put it up in demo, this is what it looks like in Python 2. It's, I don't know, slightly uglier, many people think. Certainly it's inelegant that it's a comment, but it works just as well. And it doesn't really take up any more space. So this is what we do at Dropbox. And within the next year or two, we'll be on Python 3, I think. But until then, this is what we do. That's fine. Oh, and crucially, so in this sort of highlights, is a comment. Even in Python 3, it does not affect how the code actually runs. You can go reflect on it. You can go build meta programming things that reflect on it. But normally, it does not affect how the code runs. It's only there statically, basically, for the checker. It's like a comment. But crucially, unlike a traditional comment, it's checked by machine. So you see this, and you don't have to worry, well, somebody thought this was the case, but that was a year ago, and the code has changed. Is it still true? You don't have to worry any about that, because the type checker is validating it. And of course, you have it in CI, because you have CI, you have tests. And you run this as part of that, and so it's good. Great. So just briefly, the things that make static types really awesome for Python. I've told you already about understanding code. Here's just a couple of quotes from Dropbox engineers, early adopters, about how it's made things much, much better. This is the biggest benefit, I think, by far. Number 2 is refactoring, which is a really important activity for keeping your code high quality as the things evolve, you change the abstractions to match. And a major example of that is actually Python 2 to 3 itself. This is one reason we're so keen on it working for Python 2. You put types on it first, and then many of you I hope are already on Python 3, most of you, but if you're not, you probably know the hardest part is sorting out what should be byte strings and what should be real text strings in Unicode. And that's a types problem. And when you make the types explicit to the reader, and moreover explicit to a machine that can check it and find where you have mismatches of expectations, where some code thought it was supposed to be bytes, other code thought it was supposed to be Unicode, and you can resolve that because the machine told you it's there, that helps a lot. And for Zulip, for example, in fact, that was very helpful for us transitioning from Python 2 to 3. And the third is fewer bugs. This is sort of an obvious one. I think it's actually not as important as the other two, but it's certainly valuable. The obvious thing, you'll find bugs where the type checker just sees that you've gotten something wrong. But also because you understand the code better, this goes back to the original motivation, you'll write fewer bugs. You look at the code, you understand actually what's going on, and so you don't screw stuff up because you actually know what's going on and you write better code. So that's all what makes it awesome. And great. So that was sort of the why part of the talk. But maybe you already have millions of lines of code. Most of us do have at least however much we have. It doesn't have types yet because this has only become possible really last year in practice. So most of us, most of the time, don't have the luxury of starting from scratch. So we have this existing code that doesn't have types. How do we benefit from this? And that's what the rest of this talk is about, is the how. You totally can. And just to tell you briefly the sort of data I'm drawing on here. So Dropbox, as I said, invested in making all of this possible in the first place with Guido and others working full time, and it's now pushing 1 million lines. This number is several months old, so it's, I don't know how much more it is because I left. Zulip, the open source group chat tool I work on now, is close to 100,000 lines, and it's 100% typed. And it got there about a year ago. Published a really nice blog post I'll tell you more about, I'll link to later. And Facebook is, I think, actually now the largest user. They're a little bit cagey about just how much code they have in total. But Instagram, turns out, is in Python. It's the world's largest Django application, as far as anybody knows. And they have just this year started working on putting types there. And so just in the last few months, they went from 0 to 19%, that number is from this week, of the Instagram code base has static types. And they also use Python for a lot of other stuff. All their sort of ops, their DevOps or SRE work is in Python as well, actually. And that they've also begun, and that's a huge quantity of Python code, and now an appreciable fraction of that is statically typed. And this number is going up by the week. So, and you know, as leading the MyPy team at Dropbox, I talked to, of course, other users as well, but these are the biggest. So this is the data I'm working on when I tell you how. So here's I think, the key principles, and I'll go in more detail on each of these. So one, you need to standardize how people run MyPy so that everybody's running it the same way and people don't get different sets of errors because they're running it differently. And then keep that always clean in CI, because of course you have CI, you run tests, you run this just like your tests. And then work incrementally because you can, because you actually get the benefit for the even small pieces of the code base that have types, you get the benefit there. Be thoughtful about the order that you go in, and I'll go into more detail on what to consider there to maximize your impact. And annotations should be code reviewed, just like anything else. And coming soon, there are some sweet automated tools that are not quite open source yet, but we'll accelerate it. But are totally not necessary. Dropbox has not used these tools. Zulip did not use these tools. You don't need them, but they do make it easier. So at this point, I have to apologize. I've not translated everything into Japanese. But more details. So standardize the build. You should, MyPy, the command line, unfortunately, is not as clean or as clear as it should be. And so there's a lot of flags, a lot of options. There are different ways to run it. And you don't want people to run it differently. They will get confused. You will get confused when they tell you like errors they're getting. You want everybody to run it in the same way, the same options, the same sets of target files. So you should make a script. Check it in the repo. It can be a very short script, probably, but it specifies exactly what to run it on and exactly how, what flags. And make sure everybody uses it. So make it really easy to use so they do, and make sure everybody uses it. And crucially, of course, put it in CI. Make sure it stays green. Once things work, they never stop working. Then work incrementally, adding types to your code base. Static types for Python are gradual, which is a academic jargon term that gradual types that means that you can type just part of the code base, and that part benefits. It has the benefits of static types, even though it coexists with untyped code. And of course, you benefit more and more the closer you get to 100%. But and there's maybe some small things you only get when you're closer to 100%. But it's more or less linear as you type more of it. So just get started. And we'll go in more detail on how you should do that. The order to do things, the first thing you should do, if possible, and if you have a small or a mid-sized code base, this is totally possible, you should totally do this first, is make the analysis start working. Make the basic level of analysis work. It won't be able to check everything until you go and do more work at every function, add a line saying what the types are. But it can check some basic things, and that will amplify the power of everything you do later. So do it first. The most basic, run MyPy with sort of no flags. It'll check the top level code, which is probably not much. You can't make it ignore the top level. It kind of has to do that to do anything. But that should be pretty easy to get going. You probably just add annotations to global data structures, types there. If you can, you add a flag. It's spelled check untyped defs. It's in the docs. You'll find it there. You add a flag that makes it look inside functions, even though you haven't yet given types, so it can't do a really full detailed check. It will check basic things. It'll catch you have the wrong number of arguments. You have a name that doesn't exist, things like that. And it will, as you start putting types on things, it will make those checks better because it will be seeing the call sites, and it'll be seeing the other things that interact with the code you type later. So do that if you can. And if your code base is bigger, that's fine. Just do this on part of your code base, maybe the first 10,000 or 100,000 lines that you want to work on first. Then, and at this point, of course, put it in CI. As soon as it works at all, make it never stop working. Then annotate your core libraries, anything that lots of other code will touch, because this will make the annotations more powerful on that other stuff. It'll make it better able to check. Then, this is the most important step. Once you can, you should make it a rule, make it a practice that any code that somebody touches, anytime somebody writes new code, anytime you edit old code, you should write down the types. You should put type annotations on that code. And if you think about it, this shouldn't actually really add much work at all, because if you're touching this code, you should understand it first. If you don't, you really should already be spending some time figuring it out. And if you understand it, you have some idea of what you expect the types to be. And so that understanding is really just what the annotations are. Maybe it's a list of something. That's great. We have generic types. You say it's just a list of something. Maybe it's some base class. It could be any subclass. That's fine. You can, again, our type system handles that. Really, the kind of expectations that you would have generally are in the type system. You should be able to write them down. So whatever it is that you believe about the types, you write that down. And so it's really just memoization. Algorithms do work. You memoize the work that you did to help out the next person. This is also super helpful for the code reviewer. They can better understand the code. And so that's an incentive perhaps for the code reviewer to insist if somebody doesn't do it at first, to to ask them to do it. It'll help the reviewer, and it helps everybody later. Finally, so that's the most important thing. That was the biggest driver for Dropbox, certainly, of increasing how much was annotated. But finally, once you have that rule in place, you can go back and annotate the old stuff. There's no hurry to do this. You certainly benefit. It makes that stuff easier to understand. But if nobody's touching it, maybe it's not so crucial to understand it. This is the part that crucially gets much easier once the tool that comes out soon comes out. So that's the most important. You should review annotations, just like any code. The checker won't catch all kinds of errors as long as there's other untyped code somewhere that could make something wrong. So you should actually take the time to understand the code, just like you would without types, before you write down the code, the types, and then review it, again, just like anything else. And finally, so this is coming soon, but part of how Facebook got so fast to such a huge amount of annotated code is they have built a tool that they actually run in production on a small fraction of requests whenever you touch Instagram or other Python code, that observes what types are used in real life empirically, and it logs that, and they use their log aggregation infrastructure to collect that, and that data to produce draft annotations, which then go through code review like anything else. But that very much accelerates the process. And it's some work for them to disentangle it from their internal infrastructure stuff. So it's not yet open source, but they are working on that, and they say this year. So I'm looking forward to that. That is what I have. So I hope you will try it out. Try static types on your code base. Start using them. I think the best place to start is the README. If you go to the GitHub repo, it will tell you all how to get started. There's also a great blog post that my Zulip colleague, Tim Abbott, wrote about a year ago when Zulip got to 100% statically typed. さらに記事を日本語に翻訳したことがあります。So, Python の水滴型という用語を検索してください。And I'd be glad to talk more about this anytime later today, or find me tomorrow at the PyCon JP Sprint. I'll be sprinting on Zulip, but happy to talk and help with MyPy as well. And also, or by email, or however else. Thank you very much.
Okay, let's thank Greg. All right, we have a few minutes for question time. Do we have any questions?
First, thank you for a great talk. I have a question about libraries. I kind of come from front-end world, and a few years back we tried TypeScript, and it was disastrous because so many libraries didn't have type definitions. And we recently tried TypeScript again, and it's just wonderful because all the libraries have either built-in types or type definition somewhere by third party. Now we are using some Django applications. I wonder if there is anything like type definitions repository that we can reuse from other people.
Yeah, great question. Thank you. Yeah, so that's a very important part, in fact, of the workflow. So at this stage, the main place that you'll find, so of course this matters for Dropbox and Zulip and Facebook, the main place that you'll find type definitions for libraries, actually both the standard library and third-party libraries, is there's a shared repository of type definition files. We call them stub files, PYI extension. And you'll read all about it in both the blog post and the documentation. It's called Typeshed is this main repository. Yeah, and so you can write your own for third party, but then you should contribute them to Typeshed for everybody. And I think for most things you'll probably find them there, but there's certainly more work to be done to make Typeshed better. Yeah.
Fantastic. Let me run the mic across to the next question.
All right. So I have a lot of experience with MyPy. I'm extremely happy about using it. But at the same time, for example, with the Django question, I have solved this myself for myself. One of the biggest challenges there is that if you use a properly built Python library, there's just a lot of meta programming going on. And in the Django world, what you'll discover is that since at runtime it constructs so many classes that have to do with query sets, is that you won't be able to cleanly use MyPy. And what I ended up doing is creating my own type stuffs. So stuff that should never go in the type shed. So if you want to exchange some information here about Django, I'd be more than excited to share it with you, to the guy who asked the question. But I do have a question myself, which is, what is your experience with using generic data types, so abstract-based classes, and MyPy?
Sure. Let me maybe address both things, actually. So I'm happy to talk more in detail later about Django. Zulip is a Django app. So we certainly have that experience directly. And as I said, Instagram is, which is now maybe the biggest user. You can take a look at what we do in the Zulip repo, which I don't think is perfect, but we do basically for example, the attributes on a model that are the fields, we've just put the annotation right there in the source that says what the type should be. In the long term, I think the solution will actually be to have a plugin system for MyPy, where there should be a Django models plugin that describes, there is a pretty regular relationship between the class definitions, and this is true for any kind of ORM, for SQL Alchemy, for a pretty regular relationship between the class definitions and the types that you get, but that relationship is, I think, too complex to express directly in the type system. And so we'll have a plugin system to be able to write this sort of type level description of the thing that's implemented. And happy to talk more about that, as I said. Generic types and abstract-based classes and so on. So we have generic types. Generic types for us mean things like types that are parameterized. They mean parameterized types. So things like built-in examples include list of t. You could have a list of ints. You could have a list of strings. You could have a list of t, and then for a type variable t. We also, for things like for sort of duck-typed things, the major way that people do that is with abstract-based classes, which you mentioned. And that also, if you look at, I think you'll see some of this in Zulip, certainly in Dropbox, which you can as easily look at. There's lots of sequences and other abstract-based classes that are sort of especially for all the sort of built-in standard library duck types, they're very common, like sequence and mapping and things like that. Those are there. So perhaps if I'm happy to talk in detail more later, separately.
Okay, I've got time for one more.
I wanted to ask about how mature MyPy is by now, and especially also in regards to using it as a linter, or other Python type checking tools that are out there.
Use it, meaning to
So
check
like
things other
I
than
tried
types, or-
MyPy a bit over a year ago or something like that, and I ran a few edge cases and then kind of stopped using it again. So I was wondering what the situation
Yeah.
is nowadays.
So I'll say it's evolved a lot in the last year. That's at this point more than half the time really since it started being properly developed. So I'd encourage you to try again and see how it goes. If you do run into edge cases, then please report them in the tracker, and they might get addressed, or it might be that's hard. We'll address that later. I can't promise that they'll get fixed immediately, but I guess maybe I would certainly not say that it's complete or that all the edges are polished or it's like as mature as I would like, but maybe the best measure is just how the scale is being used at, right? So Dropbox, nearly 1 million lines of code. Facebook rapidly put it on. I think if you do the numbers from the best estimates outside of how big, it's like about 1 million or more lines of code. People are using it for real, and so that's, I guess, one measure of maturity. But it does certainly, it's still a stage where somebody on your project needs to spend some time becoming not necessarily an expert like Guido or you, the people, but knowing something about it, because you will run into some rough edges, and you want to learn how to navigate those.
So you mostly were talking about running it at build time, test time. Is it also working well at write time?
As you're developing, you mean?
Yeah.
Yeah, that's a good distinction. Yeah, thank you. So, yeah, so I think you totally do it, and should where you can. I think the major challenge for that is speed. So if you have a small code base, that'll work great, and you should do it as frequently as you can. If you have a larger code base, it might take like a minute to run, which you're not going to want to run it every time you hit save in your editor at that point. I think for over a year, that's been one of the top couple of priorities for the core team, because Dropbox obviously has a big code base that matters. There is an incremental mode that helps a lot. There is, moreover, a sort of a quick and dirty, we call it, or -- quick mode, that is more incremental, that doesn't always find everything, but is most suitable for that. We've replaced the handwritten pure Python parser with something much faster that's derived sort of directly from the CPython implementation, which is very fast, which Guido wrote like 5 years ago. There's other performance work happening. I am hopeful that with Facebook also investing in it now, there will be more like oomph behind speeding it up. But that's where it is.
All right, thank you very much. Let's give another warm applause.
Thank you.
Okay, next up we have a 30-minute break until 3:40. And during this time, we want to take a picture of all the attendees as a group, and that's going to be on the first floor. So if you could gently move towards the first floor, we would much appreciate it. Thank you.